Output components, LCD display. PIC 16F84 to connect to LCD display. If you look at the diagram here, the Proteus connection, you have two lines which goes to port A, which is port A0 and port A1. This two is actually optional, up to you which port that you prefer to use. As long as there are two lines, goes to RS, and then there's another line goes to E. E refers to enable. And then the way the LCD works is you output the data in port B. Okay, here in this case we have B0 until B7, so the data is in 8 bits. You send it through the line, and then when you press enable, it will go through. Okay, so depends on you whether you want to put a command or data. Okay, the command or data depends on what is the status of the bit that goes into RS. All right, if it's 0, it's let me check. If it's 0, it goes for command. If it's 1, it goes for data. What's the difference between command and data? Command is this is the list of command. If you can see here, 0F, 01, 02. These are the command. Okay, the function for this command is related to either LCD on, cursor blinking on, cursor on, and so on, and so on and so forth. If you can see, this line goes to RS will determine the mode, because LCD display has its own controller. So the controller input RS will determine what type of operation that is this LCD is doing. RS0 means it's for command. RS1 it means for data. Both are allowed to go through when the enable pin is turned high and then low. So enable is like a gatekeeper, so that it will allow the data to go through to the LCD. RS will just determine the mode, okay, the mode command or the mode data. So if you can see, there is a list of functions under mode command. So if you send C1, you'll get jump to second line, position 1, and then cursor off, display on, and so on and so forth. So you just refer to this table for whatever command that you need to do. So the procedure is you have to set RS as 0, okay, send port A0 low, and then send this data to port B. For example, 0F you send it port B, and then you set enable stroke. Enable goes high and then low, okay, with some delay in between. Right, this is the operation, how the LCD operates. Basically, if you look at the left side of the flowchart, from start it requires LCD initialization, and then followed by LCD operation, and that's it. All right, LCD initialization consists of this from here until the end here. Okay, this is, you can assume this is like a subroutine, and then you go back here. Okay, and then LCD operation, and then the green one will go here, and then here, and then go back here. Okay, this is what actually happens during the LCD operation. So basically, in the LCD initialization, meaning initialization is on power up, when you just turn on the LCD, okay, and these are the things that you need to do. What are those? The first one, you need to provide a delay to power up. Okay, you need to give it some time to initialize itself, to do some certain codes inside itself, because LCD itself has its own microcontroller. Then you have to send command or function set, whatever that you need to set. And then you have to send command display on and then cursor blinking. After that, clear display screen. Okay, so those are the initialization. Once you have done with that, okay, go back to main program and then do the LCD operation. So what do we do in the LCD operation? Just need to have you put the data and send it port B. So like this, you have to display, you want to display hello, HEL, L, and then another L actually missing here, and then O. So these are to display hello, but you need to send as key. Initialize LCD. Okay, and then the first part is call delay. Call delay here, you have a delay subroutine ready, and then set command function set. Okay, bank select port A, and then clear flag port A LCDRS. LCDRS is the port A0 according to the circuit diagram that we have built. If you prefer LCDRS on port A3, then you have to declare it as A3. 001 here at LCDRS is referring to the bit pin number. Okay, LCDRS refers to pin number, so you have to declare it LCD_S EQU 0, EQU 1, EQU 2, 3, 4 until 7, whatever that you sorry, port A only have 5, so maximum number is 5. And then move LW 0 times 38. This is actually function. Okay, what is 38? If you look back at this table, 38 is actually command to use 2 lines and 5x7 matrix. So that's about it. 2 lines, 5x7 matrix. And then move F port B. So you send that command to port B and then call eStrobe. eStrobe is a function or a subroutine that will perform the high and low signal to enable. Okay, to enable the LCD, the data go through the LCD. And then clear F port A LCDRS again, and then move LW 0E. 0E is what? Go back there and cursor blinking off, display on. Okay, so that's 0E. And then send to port B, and then call the eStrobe again. And then lastly 0 times 01. What is command for 01? Clear screen. Remember here we have a clear screen, display on, cursor blinking. So these are the thing that we did. Okay, we did a 38 function set 38, and then display on, cursor blinking is where was it? What did we do again? 0E. 0E is okay, cursor blinking and display on. Okay, and then clear display screen, which is 01. So this is what actually is being done here. And then again, you can see here, to send a command, you set RW line to low, which is BCF port A LCDRS. So this is setting the port A0 to becomes low. Clear means 0. Move LW38 is a function set of 5x7 matrix with 2 lines. What is 5x7? If you want to display number 8, you have 5 pixels by 7 pixels. Okay, and then send it to port B and then eStrobe. And then to display data, bit set flag. Set means you make it 1. So port A1, A0 here in this case, you set it to 1. Okay, and then move AH. A is for ASCII. Okay, specific symbol for ASCII. So meaning here we are sending H, the capital, the H lowercase h to the LCD. Okay, move the port B and then call eStrobe. So every time you send a signal, you have to call eStrobe, right? So what's the eStrobe subroutine? You can see it here. This is the eStrobe. Okay, port A, bit set flag, port A, LCD enable. LCD enable is the bit that refers to port A. In this case, we have mapped it in the physical, no, not physical, simulation line, simulation circuit. We put it as pin A1. So here, bit set flag port A1. Okay, call delay bank select port A, bit clear port A, LCD enable, call delay and then return. Right. So what we do here, first of all, we set high, LCD enable high, and then we set LCD enable low. Okay, once high, delay, low, delay, and then return. So that is enough for one enable strobe. And then we have here delay subroutine. This is up to you, to your design, whatever that you need to put here. The length of your delay time. Right, so basically that's it. This is a table of ASCII character. If you don't want to use the word A just now, where was it? Here, like this one here, A and then apostrophe H. Instead of doing that, you can also do this. Okay, let's say H is here, number 68. So you can send hexadecimal 0 times 68 to port B, which also refers to a ASCII character for H. Right, so that's basically it for LCD. Thank you for watching. Don't forget to hit like and subscribe and leave a comment in the section below.